Zeros, degree, and Descartes' rule of signs. So there's a theorem about the number of real zeros of a polynomial function. A polynomial function cannot have more real zeros than its degree. So for example, if we have the polynomial function f of x equals negative 3x to the 7th plus 4x to the 4th plus 3x squared minus 2x minus 1, the degree of this polynomial function is 7. So f of x has at most 7 real zeros. Descartes' rule of signs. Okay, a polynomial function f of x with real coefficients is written in standard form. From this, the number of positive real zeros, or roots, is equal to either the number of sign changes between consecutive non-zero coefficients of f of x, or that number less an even integer. And it continues, the number of negative real zeros or roots is either equal to the number of sign changes between consecutive non-zero coefficients of f of the opposite of x, or that number less than an even integer. Okay, now that sounds complicated. Let's look at an example. So f of x, let's look at the same polynomial function. F of x equals negative 3x to the 7th plus 4x to the 4th plus 3x squared minus 2x minus 1. As we go from our first term to our second term, we go from negative 3 to positive 4, or a negative to a positive. That's a sign change. From our second to our third term, it's positive to positive, so we're not changing signs. We're not really caring about that. Then we go from positive 3 to negative 2. That's a positive to a negative, so that's a sign change. And then finally, negative 2 to negative 1, negative to a negative, that's not a change, so we don't care about that one. We have 1, 2 sign changes. So f of x has either 2 positive real zeros, or if we subtract 2, because that's an even integer, 2 minus 2 is 0, or it has no positive real zeros. So it has either 2 or no positive real zeros. Let's look at f of the opposite of x. So let's substitute the opposite of x in for x. So negative 3 times the opposite of x to the 7th plus 4 times the opposite of x to the 4th plus 3 times the opposite of x squared minus 2 times negative x minus 1. Simplify that. We get 3x to the 7th plus 4x to the 4th plus 3x squared plus 2x minus 1. Let's count the sign changes. So positive to a positive, we don't care about that one. Positive 4 to positive 3, positive to a positive, we don't care about that one. Positive 3 to positive 2, it's a positive to a positive again, so we don't care about that one. Finally, positive 2 to negative 1, that's a positive to a negative, that's a sign change. So, f of x has 1 negative real zero. If we did 1 minus 2, we'd get negative 1, but we can't have a negative number of real zeros. So f of x has to have 1 negative real zero.